So the topic of discussion for today is sum of, okay, I have not shared the screen. Yes, today's topic of discussion, subset sum problem. Subset sum problem. So what is this? We have to find a subset. Find a subset. Will be given with a set S. Okay. And these are positive integers. N positive. You have n positive integers. And this subset, so whatever numbers you select, that sum of those subsets should be equal to a given positive integer. So sum of this subset sum should be equal to given positive integer d. For example, as an example, if we will take, let's consider that these are the numbers which are given for us. Okay, and d is given as 9. We should choose the subset, choose the numbers whose sum is equal to 9. So that is a subset sum problem. So if I will check here, which are the numbers I should select to get 9? I can select 1, 2, 6, isn't it? 6 plus 2, 8 plus 1, 9. One more subset I can have, 1 and 8. Anything else? 5 plus 2, 7, 8. No, nothing. So we can form two subsets out of these numbers, whatever is given, whose sum is equal to this d, the positive integer, whatever is given. So this S is an n positive integer and you will be given with d, which is 9. You have to find subsets whose sum is equal to this positive integer d. Okay. So how do we proceed? Using backtracking. This problem is solved by using backtracking. So we will take one example also and we will solve it. This is the instance whatever we will take. The instance will be S equal to 3, 5, 6, 7 with D equal to 15. For this, we will solve this problem by using sum of subset. Now, the root of the tree represents the starting point where there will be no decisions made. Okay, the root represents the starting point where no decision will be made. After that, how we proceed is, we will have a left child which says that we are including 3 and a right child which says that I am excluding 3. So how do we proceed? Left we will include the child, to the right we will exclude the child. Okay. So in its left and right children will represent the inclusion and exclusion of S1. If we take this for a particular subset S1, inclusion and exclusion of particular number. Similarly, again we go to the left of that particular node and again their first level corresponds to the inclusion of S2, whereas right to the, so these are S1, S2, S3, S4, S5, likewise Sn we have numbers. So S1. So if we start with an empty, so here we will include S1, here we will exclude S1. Again, if we will move left, we will include S2, here we will exclude S2. Likewise, we move on. And we will move on like that until we are able to just include all the numbers and check whether we can find any subset for it. So a path from root to a node on ith level of the tree indicates which of the first I numbers have been included in the subset represented by that node. If we will move to the left, we will come to know which are the numbers which are included. If we move to the right of anything, it means that that particular number is excluded. Left means that particular number is included. Okay. So once again. Left, to the left, inclusion of a number, to the right, exclusion of a number. So finally we will have S dash. We will have S dash. The sum of these numbers is recorded in the node. So S dash every time is the sum of nodes which have been, whichever number is selected, those sum will be recorded and is termed as S dash. So if this S dash is once equal to D, we have arrived at the solution, isn't it? So if we have included 3 here and 5 here, the first number 3 and 5, 8. So what is S dash here? It is 8. So when this S dash will be equal to D, then we have got a solution. We can either, once we get a solution, we can just stop it, okay? Or if we want to find, there can be multiple solutions here. So if we want to find all the solution, we have to just backtrack, go to the node's parent and try with the other solution. If at all, if we are okay with one solution, that's fine. If usually here we will be getting multiple solutions and we will move back and try to find different solutions which are available. Okay, and in case if S dash is not equal to D, we can just terminate this saying that it is a non-promising node. So continuing here will not lead you to any solution. So we will just terminate that particular node. In case if, yeah, if it is, if S dash plus including one more number, if it is less than, if it is, one second. So adding, including a particular number, if it is greater than D, the integer, some integer whatever is given, then we will just say that it is non-promising node. When it is a non-promising node, including any particular element, the sum is greater than D. We have to find D, isn't it? It is greater than D. In this case, we will just say that that particular node is non-promising. Okay. So it will be more clear when we will just discuss one example. Let's take this itself, and how do we solve this problem? By writing a state space tree. Write state space tree and we will solve this problem. So left hand we will include the element, towards right we will exclude the element and we will find D. In each step we will include and check if adding that element, the sum whatever we get, if it is exceeding D or not. If it is exceeding D, it means that it is a non-promising. Otherwise we'll just continue. Okay. So this is a problem, that is we have to, the problem will be like this: apply backtracking to solve the following instance of the subset problem. And this is the problem 3, 5, 9, and yes, 15 here. Okay, let's do for this, and one more example I'll give, you will solve by yourself.
Certificate proposal, no objection certificate is covered. ಅವರಿಗೆ ಫಾರ್ಮ್ಯಾಟ್ ಕೊಟ್ಟಿದ್ದೆ ಮೊದಲನೇ ಮತ್ತೆ ಅದನ್ನ ಇಸ್ಕೊಳ್ಳಿ ಸರ್ಟಿಫಿಕೇಟ್ ಚೆಕ್ ಕೊಟ್ಟಿದ್ದೆ
Start with an empty set. Then what is the first element? So what do we do? Towards left, we will include the child. Include the element, not the child. Include the element. So 3 is included. So we can say that we have included 3. So that is with 3. Okay. Now, here this side, right child without 3. Okay. So this is still
ಕೇಳಬೇಕಾ ಸರ್ ಯಶವಂತ್
without.
Madam, Sridevi ma'am.
Sir, good morning, sir.
Good morning, ma'am. Idu yav section, ma'am?
Sir, 4th C section, sir.
4th B,
C, sir.
4th C section. Okay. Yav module, madam?
Sir, 5th module, sir.
CO5.
Sir. CO5.
Idu KL2 na knowledge level 2. Then which idu
Topic, sir?
19 to 23 batch?
No, sir. 19 to 23.
Okay. C section.
Yes, sir.
Okay. Okay, madam. Carry on, madam.
Thank you, sir. So we have this with 3 and without 3. Got it? Now, let's move on to the next level where we try to include the next element here. So when we move on, yes. Which is the next element we have? 5. So we will, this is with 5. Here we will just write down the sum. 5 plus 3, it is 8. Okay. Now, here, this will be without 5. So this is without 5. So when we will not include 5, it will still be 3 itself, right? To the left we will include, to the right we will exclude. Okay, we are moving in that way. Next, so which is the next number we have? 6. Okay, let's try to include that. 6. Okay, with 6, it becomes 14. Okay, with 6, this is the third number. With 6, it is 14. Now, here, to the right, without 6. So without 6, it's still 8. Now, let's check whether we can move forward. See here, 14. What is the next number we have? 7. 14 plus 7 is 21, which is greater than D, isn't it? So your yes, you have a yes dash already. Consider this as a yes dash. And adding the next number, Si plus 1, that is your 7. If it is greater than D, we have to just, this becomes a non-promising node and we have to neglect this, isn't it? See here, the sum is 14 here, 14, and if I add the next number 7, this sum is 21, which is greater than 15. So this becomes your non-promising node. I'll just write down, which is greater than 15. Hence, I will not consider this. Clear? Now, let's come backtrack here and try with this. Okay, without 6. Now, which is the next number we have? So we have considered 3, 5, and what is the next number? And we have not taken 6 here. And what are we supposed to consider now? See here, what are the numbers included and excluded? You can just check in when you pass through from root to the leaf. You can just find out which are the numbers which are included. So we have 3, we have 5, and we have excluded 6. What is the next number? 7. So let me try with 7, and this will be without 7. Okay, so 8 plus 7, 15. Okay, so this is our solution. So note down, once you get a solution, you just note it down that it is a solution. Here, without 7, it will still be 8, and there are no numbers at all to move further, and 8 is less than 15. So this cannot be a solution for you. So this is again a non-promising node. You cannot move further also because all the elements are exhausted. All the elements are already exhausted and even 8 is less than 15. So this cannot serve you as a subset, isn't it? 3, 5. Only 3 and 5 cannot serve you a subset because its value is not equal to this D. Whereas if we take this 3, 5, 7. See 3, 5 and 7, 15. So this is one solution for you, 3, 5 and 7. Okay. Now let's come back here and check whether we can move. We are backtracking here to check whether we can have multiple solutions. This is backtracking, isn't it? The problem itself is backtracking. So we will backtrack. From here we will backtrack, and we'll come here and we will check whether we can have any other solution. So with 3, 5 is also considered here. Next, let's take 6. With 6 this side and without 6 this side. Okay. Yes. So with 6, what will be the sum now? 3 plus 6 will be 9. Now we have considered 6. What is the next number? 7. So 9 plus 7 will become what? 9 plus 7 is 16, which is greater than 15. So I cannot move further. So this is again a non-promising node. I'll backtrack and come to the right. Now 3 is there. I have not excluded. I have excluded 5 and 6. So what's the next number? 7. 7 plus 3 again will be 10 only. So without 6, yes, without 6 means it's still 3. Without 6, let me write down first. It is still 3. So if I add 7 for this, it's just 3 plus 7, which is 10, and it is less than 15, and this also becomes a non-promising node. Got it? Are you getting my point? So what we are doing is we are just to the left we will include and to the right we will not include. And we will proceed like that until we can find a solution. Once if you come to know that adding any particular element exceeds the sum D, then that is called as a non-promising node. In that case, trace back. Again, you proceed in the same way. Next number, you should just check which are the numbers included and which is the next number which needs to be taken into consideration. So here we had taken 3, 5, 6. So next number was 7. So adding that, we were able to find solution. So let's move back and try with one more solution. No, we are not able to get a solution. That's because 8. If we will not include 7, it is the sum is 8 itself, which is less than 15. So this is a non-promising node. Again, I traced back and I checked with other branch. So I came to know that even these are non-promising. Hence, I'll move back and I will move to the right and check whether I can find any solution towards the right. Let me just okay. I'll take it towards this side because okay. So it is without 3. So it's still, what's the next number? 5. So what I supposed to do here? You should take care of the levels here. This is at level 1, this is at level 2, 3, 4. Now, next, what's the next number? 5. So let me try with including 5. So 0 plus 5 will be 5. Okay. Next, again, what is the next number? 6. With 6. Okay, here we will have without 5. This is without 6. Okay, we are moving this side. With 6 it becomes 11. That's fine. It's less than D still. After that, which is the next number? 7. If 11 plus 7 means it is 18, which is greater than 11 plus 7, it's greater than 15. Hence, this is also a non-promising node. I'll move back. I'll check here. 5. Without 6 means again it is 5. Next, what's the next number? 7. 7 plus 5 is 12. 5 plus 7, which is less than 15. So even this is non-promising. If it is large, if it is greater than 15 or if it is lesser than 15, it's of no use for us. Then it becomes a non-promising node. Only if it is coming to 15, then only we can move further. So just if we will look at here only, we can say that these are non-promising nodes. Now we will move backtrack and we will move to the right. Without 5, still 0. So what is the next number? 6, right? 6. With 6, it's still 6. Without 6, it is still 0. So again, this becomes a non-promising node if we will move further, because when you are 5, the remaining values, you can just check here and stop it over here. 6 plus 7 is 13, which is less than 15. Here again, with 6 means left out number is 7. Even this is 13, which is less than 15. This also becomes your non-promising node, right? So what's the idea here is, we will just try with including one number and excluding the same number to the right. Left child will represent a node where an element is considered, and right will represent a node, child node, where the element is not considered. Likewise, we move on. At the same time, we will be recording the sum here of the elements which are selected, so that if we will add the next number, if we will come to know that particular value is either lesser or greater than D, then we can say that it is a non-promising node and move back and try with the other choice. So for this, what is the solution? 3, 5, we came here, this is not included, and 7. So 3, 5 and 7 is the solution for this particular problem. We have a single solution here. You can have multiple solutions as well, as we have discussed here. See, if we will just check here, see, we had 2 solutions for this. Okay, you can try with that also. Just write a state space tree for this 1 2 5 sorry 1 2 5 6 8, and you can check, you will get 2 solutions. Okay, and is that clear? Is it clear?
Yes, ma'am.
Okay. Any doubts with the sum of subset problem?
No, ma'am.
I want everybody to answer. Like, I just put it in the chat box. If you're not able to unmute, at least unmute yourself and speak if you are okay with it. Any? Yes? No replies?
Ma'am, can you explain once again?
Yes. Yes, I'll do it. Okay, let's start again. We just do it once again itself, so that if I will just explain, you'll get confused with the values which are already available. Okay, let me just try writing the state space tree once again. Yes, we are solving the sum of subset problem, wherein you'll be given with some set of numbers and you're also given with one integer d. We have to find subset such that choosing these numbers will be equal to this d. So how many subsets we can form, that is the problem here. Okay, so by looking at this, you can just tell that you can have a single subset 3, 5 and 7. But what if the numbers are too large, and if d value is, if the numbers are too large, in that case we can have multiple subsets. So finding those manually becomes difficult, but it's easy if we will just write a program for that, isn't it? So the same, the problem can be solved by using backtracking, wherein we just try to find all the possible subsets. So what is the idea behind this? The idea behind this is that we'll start with an empty tree To the left, we will include particular number. To the right, we will exclude that number. At the node, we will just write down the partial sum, whatever we have got. Okay, and next step, we will take the next number and add it to the partial sum. And check. Once towards left, we will add. Towards right, we will not add. We will move on like that until we can find a solution. At any point of time, if you find that adding that particular element to the partially constructed sum is greater than D, then that node becomes non-promising and we will stop it there. Or if it is too small, if either this partially constructed sum is too large or too small, then obviously those are non-promising nodes. Only if it is equal to this D, then it is a promising node, and that is a solution for your problem. So for this, let's construct a state space tree. So we will usually start with an empty tree. Okay, we are starting with an empty tree. So to the left, we will include the number with 3. To the right, without 3. In every level, we proceed like that. Towards left, we will include. Towards right, we will not include. Okay, now we have included. Next. Yes. What is the next number now? Which is the next? So I should write down the partial sum over here. After including, I have the sum as 3. It is still less than 15. I can move further. Yes, because I have elements also. Still I have elements as well. Now, yeah, with 3. Now, what's the next number we have? 5.
5.
Yes, I will just include 5 and check. 3 plus 5, 8. Yes, I'm including. Here, I'll just exclude that and also write down without 5. So, without 5, it is still 3. Okay, now moving further, 5 is over. Now, next number is 6. So, I just add 6 with 6. So, 8 plus 6, it becomes 14. Okay. So, here, I'll just write down without 6. Without 6, it's still 8. Okay. Now, here, what's the next number I have? I've taken 3, 5 and 6. What's the last number? Number which is left out is 7. Just check here. Add this number to the partially constructed. This is called as S dash. And this is Si plus 1. Add this. 14 plus 7 is how much?
21.
It becomes 21, which is greater than 15. So I cannot take this. Right? Now, I'll move back and check towards this. I'm coming here. 8. So what is the next number I am taking at this level? It is 7. So 8 plus 7? 8 plus
15.
Yes. So with 7. So 8 plus 7 becomes 15 here. I've got solution, isn't it? This is a solution. Because your D is 15. We have to find the combination or subset of numbers whose sum is equal to this D. So we have got a solution here. We can just stop it here, or else usually we will try finding all possible solutions. So what we do is we just move backtrack and we will check again here. Okay. This was with 7, now without 7. Without 7, it is still 8. Now this is a final sum. That is because we have done with all the numbers 3, 5, 6, 7 levels. 3 here, 6 we have considered here. Then 5 considered here, 6 we considered, 7 in this level we are considering. So we are exhausted with all the numbers. Still it is 8, which is less than 15. So this is a non-promising node. Okay. Next, we will move back, we will backtrack and check at this level now. So without 5. So this is 5 by including, by considering the number 5. We are left with 6 and 7. So let's add 6 with 6. So 6 plus 3 becomes 9. Okay. And this without 6, it's still 3. Now, what's the next level? We have to add 7. We have considered 6 in this level. Next is 7. So 9 plus 7 is how much? 9 plus 7, it is greater than 15. So this is non-promising node. Okay, let's check here. 3 plus 7 is just 10, which is less than 3 plus 7 less than 15. This is also a non-promising node. Got it? Then we will move back. And we'll move to the right and check whether we can find any other solution than this. Okay, without 3 we have. Now, what is at next level? We should consider 5, isn't it? Towards left with 5. Towards right without 5. Now, 0 plus 5 is 5. Okay. Now, next level, what is the next number? 6. So, with 6, it becomes 6 plus 5 becomes 11. Here, without 6. Now, let's check here 11. So, what's a number at the next level we will consider? 7. 11 plus 7 becomes 18. 11 plus 7 is 18, which is greater than 15. So, this is a non-promising node. plus 7. Okay. Now, again, we'll move back and check. So, 5 without 6 is still 5. So, what's the number we are taking at this level? 7. 7 plus 5, 12. 5 plus 7 is 12, which is less than 15, and this is also non-promising. We didn't end up finding a solution. Again, we'll backtrack and we will check. Without 5, it is still 0. So, at this level, we have to take 6. And if you will check here, you can write down or you can just check here. 6 plus left out numbers are 6 and 7. 6 plus 7 is 13, isn't it? So, 0 plus 13. You can write and show in steps, or you can just end it like this, because once you look at here only you can just say whether you add or include. It's 6 plus 7 remaining numbers, because 3 and 5 we have not taken into consideration. 6 plus 7 is 13. So 0 plus 13 is obviously less than 15. So this side also becomes this is also a non-promising node, and we can end up here itself, or you can move further and show it in the same way. It's one and the same. 0 with 6 means it becomes 6. Then again 6 plus 7, 13, less than 15, you can say it. And towards right, you can just say, you'll be 5, if you include 6, if you exclude 6, it will be 0 itself, 0 plus 7, less than 15. Or else you can end here itself, because it's very much clear that 6 plus 7 is 13. And whether you include or exclude, it will not be greater than 15. So you can just end up here. So this is the only solution available. So what are the numbers which are selected? 3, 5, and we came here, 6 is not included, and then 7. So 3, 5, 7 gave you the solution. This is a subset. Okay, now clear with it?
Yes, ma'am.
Okay then. I'll give you a problem, you will solve it, right? If you will solve by yourself and come out with doubts, then you'll understand it better. So we have this, you have to apply backtracking for this subset and find 1, 3, 4, 5, and D is 11. Will you find?
Yes, ma'am.
Solve this and send the snapshot. Note down this problem. Apply backtracking to solve the following instance of the subset. Yes, 1, 2, 1, 3, 4, 5 and DB 11.
ಮಾಡಿ ಸಾಕು ಮಿಸ್ ಅಷ್ಟೇ ರೀ.